Welcome to my first video tutorial on light. In this video we will discuss the reflection of light. Let's start. We are able to see the beautiful world around us because of the light. We can able to read a book. We can able to drive a car. We can able to watch a television just because of the existence of the light. So we can say that light is a form of energy which enables us to see the things around us, and we detect the light with our eyes. We cannot see any object in the dark room. The light enables us to see the objects from which it comes. For example, the sun. We can able to see the sun because the light rays coming from the sun falls on our eyes. So here the sun is emitting the light on its own. So such objects are called luminous objects. The other examples are stars, fire, candle, electric bulb, tube light, etc. The light also enables us to see the objects from which it is reflected. For example, the flower. Here, the flower is not emitting any light on its own, whereas it is reflecting the light which is falling on it. So, when the reflected ray falls onto our eyes, we can able to detect the flower. So here we are calling the flower as the non-luminous object because it is not emitting any light on its own. So other examples are the table, chair, and so many things. Our next topic is optical medium. Optical medium means just a material through which light propagates. We have mainly three types of optical mediums. The first one is transparent medium. Transparent medium is the medium that allows light to pass through it. Example, air, glass, pure water, etc. The second medium is translucent medium. So the translucent medium is the medium through which light rays can pass partially. Example, fog, butter paper, ground glass, etc. The third medium is the opaque medium. Opaque medium means the medium through which light rays cannot pass at all. Example, metal, wood, etc. Let's get into the main topic, that is the reflection of light. Consider two mediums 1 and 2, and this is the boundary between the two mediums. Say this is the light ray falling onto the surface, and if the light ray is sent back into the same medium. See here, the light is coming from medium 1, okay, and it is sending back into the same medium, okay, after falling onto the surface. This phenomena is called the reflection of light. So we can say that the bouncing back of light into the same medium is called the reflection of light, and the light ray which is falling onto the surface is called the incident light ray, and the light ray which is reflected back, sent back by the boundary, this is called the reflected light ray. So in this phenomena, reflection of light follows two laws. the first law. In order to discuss the first law, we need a normal perpendicular. Normal means perpendicular onto the surface, 90 degree here. So we have to draw a normal at the point of incidence. So this is the incident ray. So here it is falling onto the surface. So this is the point of incidence. So normal is required at the point of incidence. So according to laws of reflection of light, the angle of incidence, that is the angle between the normal line and the incident light ray, is equal to the angle of reflection, that is the angle between the normal line and the reflected light ray. So they are equal. Theta I equal to theta R. Suppose if this angle is 30 degree, angle of incidence is 30 degree, this part also angle of reflection also 30 degree. So this is the first law. It also has one more law. It also follows one more law, that is the incident light ray, reflected light ray, and this is not the light ray. This is the just a normal line. Okay, imaginary line. So this is the normal line. These three things lie in the same plane. So this is the second law. Now, types of reflection of light. There are two types of reflection of light: specular reflection of light, diffuse reflection of light. Specular reflection of light is also called regular reflection. Diffuse reflection is also called irregular reflection. The specular reflection of light takes place from the smooth surface, like for example plane mirror, whereas the diffuse reflection takes place from the rough surface, for example the surface of a sheet of paper or the surface of a wall. In the specular reflection, all the reflected rays will be parallel to each other, whereas in the diffuse reflection, the light rays are not parallel to one another after reflection. They travel in different directions. In the specular reflection, the clear images are formed, whereas no image is formed in the diffuse reflection. The best example, the images formed by the plane mirror, whereas the diffuse reflection, they don't form any image. See here, we can able to see ourselves in the plane mirror because of the regular reflection from the plane mirror, whereas we cannot see ourselves in the plain sheet of paper, okay, because of irregular reflection from the surface of the paper. Okay, whatever it may be, whether it is a regular reflection or irregular reflection, our two laws of reflection are obeyed. For example, here, so this is the normal at this point, this is the point of incidence. So our two laws are angle of incidence equal to angle of reflection. This law is obeyed, and the incident light ray, the reflected light ray, and the normal, these three lie in the same plane. This second law also obeyed here in the specular. Let's see whether the two laws are followed or not in the second type of reflection, that is the irregular reflection. Okay, so here also the two laws are obeyed. For example, at this point of incidence, so the same rule is applicable: angle of incidence equal to angle of reflection, both are equal, and this incident light ray, reflected light ray, and the normal also lie in the same plane. Even let's take here at this point, draw the normal at this. See, they are oriented in different direction. after reflection just because of irregular surface. But the diffuse reflection also follows the two laws of reflection. So here also at this point of incidence, angle of incidence equal to angle of reflection, and incident light ray, reflected light ray, and the normal line at the point of incidence, all the three lie in the same plane. So finally we can say that whether it is a specular reflection or it is a diffuse reflection, okay, it follows the laws of reflection. Our last topic is retroreflection. Retroreflection means if the light ray falls onto the surface perpendicularly, and if it bounces back, if it traces back the same path, then we call it as retroreflection. In the retroreflection, the angle of incidence is equal to angle of reflection. Of course, both are equal to 0 because all the three on the same line. Here also we have the normal line, and we have incident light ray, and we have reflected light ray. So the angle formed is 0 here. Clear? If the light ray after reflection returns back to the same path as the incident ray, then such type of reflection is called retroreflection. So angle of incidence equal to angle of reflection, which is equal to 0 degree. Let's do a problem based on reflection of light. Okay, so based on the first law of reflection, here it is given, okay, a light ray is incidenting onto a surface. This is the point of incidence, and it is reflecting in this direction. Suppose if this is, what is this angle? The normal and the reflected light ray. So this is the angle of reflection. Angle of reflection is given. He is asking the angle of incidence. How much is the answer? Yes, 60 degree. According to first law of reflection, angle of incidence equal to angle of reflection. So the answer is 60. Very simple. Baby sum. Okay. One more problem for us. Okay, just the difference is now it is oriented in different direction. Whatever it may be, this is medium 1, this is medium 2. The light is coming, incidenting, falling onto a surface here and bouncing back into the same medium 1. So what is given this time? Angle of incidence is given 55 degree. So we have to find the angle of reflection. Yes, very simple. Yes, 55 degree. One more problem. Okay, this time same. This is also reflection of light. Light is falling onto a surface and bouncing back into the same medium. So again a problem on the reflection of light. So this time the angle of incidence is not given. Angle of incidence means the angle between the normal and, see the arrow mark, angle of incidence. So this angle is not given, whereas the angle between the incident light ray and the surface, the boundary is given. So here this is 30. So what we can do, we know that the normal and the boundary, the total angle here is 90 degree. Out of 90, just you remove this 30 degree. So this become 60. If this is 60, this will be 60. Clear? Let's do the last problem. Okay, so far we have done the problems without using pen and paper. Okay, such a simple problems we are doing. Of course the last problem also simple. Let's try. So here in this problem, two mirrors are given, mirror 1 and mirror 2, and they are kept perpendicular to each other, 90 degree to each other. Now first a ray of light is incidenting on to a mirror 1 with an angle of incidence 60 degree. That's it. Here we have to find the angle of reflection from the mirror too. So let's solve this part first. Okay, it's very clear that this is the angle of incidence, the normal and the incident light ray. So now first we will find the angle of reflection from the mirror 1. So very simple. So which is also equal to 60 degree. Now we have two options. Now we can go for this right angle triangle, one option, or we can also go for another right angle triangle. Both are the same. The option is yours. Okay, now if this is 60 degree and these two normals also making 90 degree here, okay, in a right angle triangle we know very well that, okay, one is 90 degree. Okay, so it means the sum of the other two angles here and here will give us 90 degrees. So this is 60 gone. So it means this angle is, yes, how much? 90 minus 60. So which is equal to 30 degree. Once this is 30 degree, we can apply the same angle here. So the final answer is 30 degree. Very easy. Okay. I hope you understood. All the best. Thank you very much.